I've got this tiny little piece of board, circuit board. I've got some captain tape on it at the moment because it's what I cut off that other one. I was making it, and you're probably thinking, well, God, that piece of board, and we look at the size of it, it's about the size of my thumb. What could I possibly build on that? Ha. Well, waste not, want not, as they say. This is my 3D representation. It's simply a 79L negative voltage regulator. That's what I'm building. This is just a 3D virtual. It's basically got 3 terminal blocks, which are the big red things, which kind of don't really look like terminal blocks, and the 2 blue things are capacitors, and the little red thing there is the regulator, and then there's the 2 diodes, which is one at the back there. So basically, that's what I can put on this little piece of circuit board. So anyway, the reason for doing that is my circuit board works great, but the relay circuit has a tendency to cut out, and the relay disintegrates. Disintegrates. Oh, I don't know where I'm getting these words from. It disengages actually before the voltage drops off. You know, it gets about 6 volts, even though the boost regulator is still operating. The relay disengages. So what I'm going to do is make that little regulator board, and it's going to be wired to the boost converter. And the reason for the 2 diodes on the boost converter is that one diode will shunt power from the boost regulator back to the regulator board, and the regulator board will drive the relay board with the timer circuit on it. So, and the other diode will be connected directly to the supercapacitors. Oops, I've got all wires in the way here. So that when the boost converter is not in operation, it has to get its power from somewhere. So it will take the power from the supercapacitors, which will keep the relay board energized so that when it's tripped, the power will automatically switch over to the boost regulator, which will keep the relay energized until the power is completely depleted, at which point, it doesn't matter anyway, and the relay will simply be disengaged. Anyway, that's what I'm doing here at the moment. And I also put a bigger capacitor on my relay board for the timing circuit to keep it active longer. Made quite a few improvements to the board because the timer board kept picking up transient interference. So what I did was put a ceramic disc capacitor between pin 2 of the timer, 555 timer, put a capacitor between pin 2, a ceramic disc that is, and ground. I also put a ceramic disc capacitor between the pins on the supply input to get rid of any transients, which I was getting pulses, high frequency pulses, which were causing it to false trigger when I didn't want it to. So that's been sorted out. As you can see, the problem is the relay circuit is active, but the relay is not. That is what I'm trying to overcome. There's no power going to my battery at the moment because there's not enough power to kick the relay over, and that is the reason why I'm building this circuit, to overcome the lack of power to the relay circuit. Thanks for watching. Yay! Well, my little board is come out okay. Yeah. Oh my God, covered up my thumb. Either I'm very big or it's very small. Yeah, I did the pattern. I wasn't going to bother, but I thought, well, might as well let's see if it works. Still doing tests on it. And the pattern's come out pretty good. Amazed I managed to do it actually without any jumper leads. Ooh. Yeah, all cleaned up, ready to etch. Oh, there's a bit of paper on the other side. Stuck to the board still, but That soon rubs off. Yeah, it takes a while to get it off, but no worries. It's mainly come up in the water, I think. It's just a bit of glue left off of the transfer paper. Yeah, the white powdery. It goes white like glue. Fingernail gets it off as well. Yeah. Still come out quite well. Well, really good actually. There was one thing though, that track on this side, right near the edge. Ooh, very close to the edge, but it's okay. That's fine. Would be better with the magnifying glass. Looks a bit sharper then. Mind you, the writing was a bit too small this time. Doesn't really matter. Yeah. So, as long as I can read it. Well, all etched. All etched, all clean. Hang on a minute. Magnifying glass again. Oh God, I can hardly hold the damn thing. Yeah. Oh damn. I've got a short, that top, the border line, the line that goes on the circuit board at the top. It's touching both tracks. No, that's always. I can easily scrape that off with a knife. Just thin, tiny bit of copper. Just realised actually. Oh, it might not be touching at that corner. Maybe not. Well, we'll soon find out. Yeah. I'll test it with a meter. At last, the real thing. At least I haven't got anything one way round. The dial's in the right way. I actually used some of my older capacitors because the ones that I already have, anyway, not really old, but just the ones I had legs cut off already. I thought, well, rather than waste the new ones, because, well, they are new. I'd used them before, but took them out and changed them for something else. And I thought, well, I might as well make use of these. It's only a power regulator. Nothing fancy. All soldered. Just got to do some tests on it now. Make sure it's all working. And no short circuits. It's very simple though. There's nothing much can go wrong with it. Yeah. Got the terminal blocks where I stick my wires in. 2 inputs and 1 output. So I can sample 2 different DC voltages. Yeah. And the regulator, actually, it's a 79L12. It's built-in thermal shutdown, limited to 100 milliamps. It's over temperature, short circuit protection built in, so doesn't need any fuses, because if it's shorted, it automatically shuts off. So you got to love some of these modern day technology. One little IC looks like a transistor though, but it isn't. It's an IC. It's a regulator IC. So anyway, there we go. All done. Right, I've done it. I've put a wire from the boost step-up converter output. I've got to solder that on actually, and I've tucked it underneath my rubber foam and wrapped it all the way around underneath the foam so that it's up underneath. That way it keeps it all snug and out of the way. And it comes all the way around and goes to my one of my inputs. Actually, I only need one ground, so I've got both ground wires going in there, and for the input really. But and my other red wire, other input, DC input, comes directly from the supercapacitors. So when when the supercapacitors are being discharged and the voltage is dropping, that's when the boost regulator is active, and that's when the power comes in through here, and it's regulated down back to 12 volts because the boost regulator steps you up to about 18. It's a bit high for the relay circuit, so it goes through the regulator circuit through the wire and supplies the regulator board. The only side effect, the only drawback is that I can't have a second ground on the board, so I've used a screen lead for the signal for the input for the trigger circuit. I've used a screened wire. It's earthed at one end, but the earth wire is not connected at this end because it's a negative voltage regulator on this other board. And if I shorted that ground out to this, then I would get the full 18 volts going in. So I've had to isolate that other earth point, but that's nothing, that's irrelevant. The point is signal gets in and it goes through this capacitor anyway, so and I can't see any drawbacks since the voltages are the same, will be pretty much the same, and the capacitor will just compensate for any slight deviations. Anyway, yeah, so I've just got to solder that other wire on now. Which is, I better do it now actually, because that's one thing I'll forget to do if I don't. Now I've got it soldered. It's nice and solid, won't come off. Anyway, we're ready for another test, I think. So I'm going to charge it up gradually on my limited current supply, and it's about 150 milliamps gradually, and see how things work out. Oh, actually, before I do that, I actually did take the other board, the MPPT. I took the MPPT out of the hall, and actually I'm going to mount this on here as well. So I'm going to find somewhere to put that. Actually, I might stick it over here, or move that board up and put it at the bottom. Actually, that will be better. So, another little job to do. So, finally got the MPPT wired up. I've got two outputs now. I've got the output from the MPPT, and I've got the output directly from the boost regulator, so I can do a comparison, and, well, if I have problems with the MPPT, I can just use the other one. But I am trying to get this working because it does save power. I mean, obviously, it turns the output off during the times when the voltage is too low, which is to my advantage because that's when the power's going into the supercapacitors. That's the reason why I want to keep it running if I can. So wire that up, the input to the boost. Yeah, this is getting a bit cluttered, I know, but it's okay so far. But I put the elastic band on because I accidentally broke the thermal compound bonding to the metal bracket underneath. It came loose, so just had to put some more thermal compound on and let that dry. I put elastic band on to hold it where it sets. Yeah, it's going to take a while. Actually, yeah, I thought it got cockeyed, but no, it's alright. Anyway, I'm going to test the relay in a minute. Start putting some power in. My LED always ends up getting bent. Right. So, yeah, I put this foam around the supercapacitors just to prevent any shorts between the circuit board and the cases, the metal cans of the supercapacitors. The foam's quite thick actually, much thicker than the legs of the components are on the board. So my regulator's all wired up. I need to sort this meter out at some point. You still have to sort that resistor out of that. Anyway, but that can wait. It's not urgent. Yeah. Well, at least I've got it all in one place now. It makes it a lot easier to set it up. You know, I can twiddle pots and tune it without having to run backwards and forwards, which is doing my head in, actually. So, yeah. We're slowly getting there. The MPPT light come on, which is good, because sometimes it didn't come on. I'm not sure if I had a bad connection on it, but yeah, MPPT turned on, but voltage on the MPPT at the moment is 0.09, so it doesn't access any power out anyway until the voltage gets to a reasonable amount. God, I've got problems. Turns out because the voltage being lower on my relay board, I was getting a technical problem, whereas the voltage on the trigger circuit wasn't working, and I found out why. It's because the voltage was higher on the trigger circuit board than it was on the relay board, only about 1 volt. But because my capacitor on the board, the actual capacitor I would put on the board, which was this blue one at the back, this blue one, the polarity actually is negative, goes to the output of the socket. And because positive was coming into the socket, it was affecting my circuit. So I had to tag another capacitor back to back temporarily for now. So it looks like I'm going to have to find myself a bipolar capacitor, or just, yeah. Well, I could just actually reverse the polarity of the one that's in there. It should be fine. Anyway, the circuit's working. Battery power's just about to go off. Oh, it's still getting a trickle. Anyway, it's discharged completely now, so that's good. The relay stayed on a lot longer, and they actually disengaged as soon as the power was almost totally discharged. And obviously, at the moment, we've got to wait for the relay to time out completely, because it hasn't timed out completely yet. But once it does, anyway, it doesn't matter even if it does or not. This is charging back up again, so yeah. Oh, it's not actually charging. Relay still engaged. But it'll time out at some point, and then I have to back off the preset a little bit on the meter, on the timer circuit. Just a fraction. Yeah. Because we want it not to be on too long. Anyway. It's a lot easier to set this up now, because I can set the MPPT a lot easier now, because I can see my battery while I'm doing it. I couldn't do that before, it was difficult. Right, ready to put back up. It's working great so far. I'm just going to wire it all back up to my... Yeah, it's running on its own power at the moment. There's nothing attached. It's just a supercapacitor that's running everything. So, yeah, the reason it keeps going blue is because it thinks the battery's charged, because I've just got a capacitor on the end at the moment. But once it's hooked up to the battery, once it starts to charge the battery, then that blue light won't come on, it will just stay red. So, right. So far, so good. Oh, I actually put a little button on the back of this meter. I found out that the meter has a little function on it that you can enable, toggle on or off, whatever. Basically, it goes into a cycle where it charges, and then it disconnects. It sort of pulses, the charge to the supercapacitors, and I thought, oh, that's interesting. Must be some kind of diagnostic or something. But anyway, it's worth knowing about. So I've got it all wired back up. It's very dull outside. There's hardly any daylight at all. It's just very foggy and murky. So I've hooked up the solar panels, and we're not seeing any joy right now. I'm not surprised. It's twilight. Yeah, it's not even enough really to run the meters or anything. So it's probably going to decline. So, right, thanks for watching.